Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at cubics as part of the A-level mathematics syllabus. So firstly, let's just look at the general shape of a cubic. So this is just a straight line graph. Y equals x goes from bottom left to top right. This is y equals x squared, so it's a beautiful curve and it goes off to from top left to top right, sort of dipping in the middle. This is y equals x cubed. This is the most simple cubic, and it goes bottom left to top right, and it has a kind of flat bit in the middle which we call a point of inflection as it goes through the origin. This is y equals x4, which is similar to y equals x squared, but it sort of has a flat bottom. It also has higher values. It's going up to like 1200 here, rather than, I mean, we probably, what's the exact thing? And we should all know 1296, right? That's 6 to the power 4, because 6 sixes are 36, times 6, I'm scaring myself here, is 216, times 6 is 1296, because 6 times 200 is 1200, and 6 times 16 is 96. I don't know why I'm bothering doing this, but anyway, it's fun. This is y equals x to the 5. I will not be doing 6 to the power 5, but I can tell you now that it's 7776. Bigger numbers, and also a more flat inflection point, because basically higher powers make small numbers smaller. They make numbers less than 1 smaller and numbers bigger than 1 bigger. But also it's just to look at these shapes where the odd powers are going bottom left to top right and the even powers are going top left to top right. Yeah, it's pretty. Okay, here's an example cubic. X cubed minus 2x squared minus 5x plus 6 equals 0. Firstly, we've got to find a number that fits in. Now, as it happens, 1 fits that equation and minus 2 does, but I started with 3. If you put in 3, you get 27 minus 18, which is 9, minus 15, which is minus 6, plus 6, which is 0. So we can then divide by x minus 3. There's a video on polynomial division, which I will link in the description. We divide by x minus 3 and we get x squared plus x minus 2. I mean, we can actually, instead of doing polynomial division, you can actually work it out in your head. When I was doing these videos, I sort of worked it out in my head, but polynomial division is the right way to do it. X squared plus x minus 2 then factorizes into x plus 2 times x minus 1. So we've got a solution that for these three things multiplied together to be 0, one of them must be 0. So for this to be 0, x equals minus 2. For this to be 0, x equals 1. And for this to be 0, x equals 3. So then it's hitting the axis at minus 2, 1 and 3. And we can see here's a beautiful drawing of the curve that shows that. Here's another cubic, x cubed plus x squared minus 20x equals 0. We can see that x is a factor, so we take that out. X squared plus x minus 20 times x equals 0. Then we factorize this bit. X plus 5 times x minus 4 times x equals 0. So for this to be 0, either x is minus 5, x is 4, or x is 0. And here is the very pretty chart that shows that, minus 5, 0 and 4. It's got a beautiful, much more of an undulating sort of shape, hasn't it? I thought I'd do one with a minus sign at the front, because when you put a minus sign at the front, instead of going bottom left to top right, it goes top left to bottom right. And if you put a minus sign in front of a one of these ones, like a quadratic, it turns it upside down. So if you put y equals minus x squared, it just turns it upside down. So instead of a U, it's like a dome. So we turn from this to this. Minus x cubed minus 6x squared minus 5x plus 12 equals 0. And basically, we don't go to the end quite yet. If you put in 1, you get minus 1, minus 6, minus 5 plus 12 equals 0. So you get kind of minus 12 plus 12 equals 0. So divide through by x minus 1, you get minus x squared minus 7x minus 12. Take out the minus 1, x squared plus 7x plus 12. And then this factorizes into x plus 4 times x plus 3. So our roots are 1, minus 3 and minus 4. Look just like this. There's 1. Minus 3 and minus 4 are slightly clustered together. Wasn't that fun? I hope you liked this video. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas. And most of all, I hope you enjoy your mathematics.